Welcome to the last session of the day and of the 2 days. We're here. We're going to take into the challenges and trends in video at scale, and we're joined by some awesome people from across the industry to go through a few really interesting topics over the next 40 or minutes or so. So I'm going to start with some intros. Hi, my name is Tim. I'm an AM here at Meta, and I want to hand over to Tamar. Can you give us your name, your company, and what got your company, what got you here today, and then we'll move on.
Well, hi everyone. I'm really happy to be here with this esteemed team of panelists, wrapping up what appears to me to have been a very strong video at scale event. My name is Tamar. I'm an electrical engineer by training and have spent over 20 years in the field of algorithms for video processing, compression, and video quality. My story is tightly coupled with the story of Beamer, where I'm the CDO. And having been on board since inception, I've had the pleasure to be part of our exciting journey. We build perceptually driven video encoding and optimization solutions. The optimization process uses our Emmy Award winning quality measure, so cool, and it reduces bitrate, creating perceptually identical, fully standard compliant video bit streams. We're also grateful to have an amazing partnership with NVIDIA and are currently working on the launch of an NVIDIA-powered video optimization SaaS product. I'll also add that I'm located in Israel. I'm a mother of three, and being an Australian-born religious Jewish woman, I try to be a voice for diversity in the tech world.
Really cool. Thank you, Tamar. It's awesome to hear. A lovely introduction. Roberto, I'd love you to answer the same questions. Give us your name, the company, and what got you here today.
Hey, I'm Roberto Peon, and I am from Meta. And my journey here started with autonomous flying model helicopters. It was an interesting project, and part of what we needed to do there was to perceive the world around us. It turns out that requires video. And it also turns out that problem was close to intractable. So instead of doing more flying autonomous helicopter things, I ended up doing special effects stuff. And from there, I went to doing augmented reality for live sports TV. And so as far as I know, that stuff is still happening, which is kind of fun to see. From there, I took a sharp left into networking and distributed systems and network protocols and standards. That was fun for a while. I did some things that people probably are still using. And then I went back into video because video is really a bunch of really hard computer science problems, and I love the hard problems. It really makes me tick. I kept doing that when I joined Meta, and did that for a good long time. And now I'm also looking into VR and AR, which of course is a combination of the generation and the recording and display of the pixels.
Really cool. Thank you, Roberto. Exciting. I thought you came in via an autonomous robot, so I was excited by that. But I'm going to hand it over to James. I'd love to hear name, company, and the journey that got you here today.
Absolutely. Yeah. My name is James Broberg. I'm founder and CEO of Streamshark. It's always hard to summarize the journey, but I guess I started in academia as a bit of an accidental academic, working in distributed systems and load balancing algorithms, but sort of moved on to the commercial world and started off in the CDN space in sort of fairly novel at the time, multi-CDN optimization strategies. And then I guess rode the tide of video from sort of 2014, 2015. And now at Streamshark, we're just laser focused on, true end-to-end workflows. We just like to solve customers' hard problems, basically. So everything from signal acquisition or content acquisition all the way through to play out and everything in between. We're focused on making, closed loop systems that, we hope make our customers' jobs a lot easier and de-stresses the challenges that are just growing in terms of delivering really rich content to increasingly complex and powerful end user devices.
Really cool. Thank you, James. And to finish, our panelists, Haixa, I'd love to hear an intro from you and the journey that brought you here.
Hi, everyone. Really glad to join this. My name is Haixa. I am a software engineer at Meta in the Instagram media platform team for the last 5.5 years. My story probably started around 18 years ago. I had joined the workforce in Silicon Valley as a software engineer. The first job is actually at NVIDIA, and I was having an interest in video to start with. And my first job spent about 7 years on various playback, video decoding, and firmware driver solutions. And after that, I also worked at Google and Apple on various projects related to video encoder. What really got me here in Instagram and so excited about is the scale and the fact that we're serving billions of active users. And along with it, like the huge challenges that before that I was not that familiar with. So I feel like this is a completely new horizon and super, super interesting work.
Really cool. Thank you, Haixa. I'm really excited by the breadth and the depth of our panelists here today. It's awesome to have so much knowledge in this room. I'm going to dive into our first topic. And I want to ask, when we think about maintaining consistent quality of experience, it's always like a key component of delivering live and on-demand video at scale. And the users of these services are becoming more and more demanding in terms of expectations around lower latency, in terms of rich content and quality and of immersive content and the experience. What tactics and trends do you see from an observability and optimization perspective to address these challenges? Haixa, I'd love to come to you first on this topic.
Yeah, on this topic, I will probably start from the approach of where everything starts, which is the video ingestion. So even though I think quality of experience, people usually talk about consumption, what actually goes into the video pipeline really plays a huge role in terms of the visual quality, in terms of reliability, in terms of like error detection. A lot of the things of the homework that we do when the video was first ingested. And I believe that this is super important. And I think one of the trends that I see is that we're doing more and more of the pre-processing in terms of detection, in terms of like trying to optimize the encoding recipe based on the type of content we receive. And this has like a huge impact downstream in how much of a visual quality and quality of experience we can deliver. Yeah, I would...
Really cool. Yeah, I totally agree with that method of the beginning, garbage in, garbage out. So like if you can put the best quality thing in, the output's going to be so much better. Roberto, I want to come to you next to talk about your thoughts on this topic.
Sure. So I would love to replay Haisha's topic and play at the beginning here because it all starts at the beginning, as he pointed out. And at the start of the stack, we have better sensors these days. The cameras are just so much better. You have in your hand what you would have paid hundreds of thousands of dollars for not that many years ago. And it has driven a lot of change everywhere. So it's driven us to better codecs because we just have a very wide need. You can't spend your way out of this problem like you could when we only had a few cameras that were really nice. And then now we need better protocols because there's more people slinging more bits for more pixels around, and they have more of an expectation of interactivity than they did before. And that's a really fun, hard challenge. And that leads us also to the fact that we need better algorithms for choosing how to manage what bits and what quality to send and figure out what the network is doing that might make it hard to do that kind of thing. So I think it's also really interesting that the difference between live and not live is also getting smaller. And I think what we're seeing is that folks are playing around with what that means. And so the differences exist in the architecture of various parts of the stack, but the quality of experience is really the differentiating factor between a lot of different product stuff right now.
Yeah, really cool. And even this conference is a good example where we're blending live and pre-recorded content in a very dynamic way. And it's really exciting to see that. Um, Tamar, how do you see these challenges in your universe?
So I would probably focus on the quality of the video as an important factor in the quality of experience. And we've seen a huge leap in the awareness of the industry for actually the importance of incorporating perceptually aligned quality measurements into the loop. And I think actually the talk given yesterday by Meta's Denise Noyes is an excellent case in point of how we're moving towards finding better quality measures to do the work and have them in the loop to get an overall better quality of experience. Years ago, when Beamer started with, quality driven encoding, the discussion was generally, why would you want to do that? And companies that did something related to quality at the best case used PSNR. And we've definitely over the last decade, guilty as charged. Over the last decade, we've seen an evolution, in large part thanks to VMAF, donated by Netflix. And nowadays, nobody asks, why do you care about the perceptual quality and why would you want to measure it? It's how do we do it and how do we do a good job of it and how do we really make sure that it's perceptually aligned? Now, of course, it's always a balance, right? And if you reduce bit rate and maintain perceptual quality, where do you get the extra compression efficiency from? And I'm sure we'll touch on future codecs as we move on in this discussion. But to me, bottom line, it's about getting better compression efficiency, using everything at our disposal while keeping our eye on the ball for the visual quality. That's a pun.
It's the big one.
And making sure that we are using the best approaches and using all the tools we have to measure the quality in the loop. And that will yield the better quality of experience. Again, it's one factor. It just happens to be one that's particularly close to my heart.
Yeah, in loop quality measurement is a really exciting development. I had off camera, I had an exciting reaction when you said PSNR because my doctorate, I use PSNR as my quality measure because VMAF didn't exist yet. But that's why I was like, oh no, on that side.
It used to be that every paper we read that started with, PSNR is a terrible metric, but we're going to do everything with PSNR. I was like, forget
it. Guilty on that side. That's so cool. James, I would love to come back to you to close this topic for us and look at the end to end. I hand it to you.
Yeah, absolutely. I guess given my background and my company's background, particularly originating in the CDN space, we're quite focused on deliverability and observability, and I think the advances that have occurred in that space in the last 2 to 3 years have been pretty phenomenal in terms of just understanding more about the actual client side experience. And I guess, moving to a standards-based approach to do that, that's kind of, compatible across vendors as well is a huge advancement. So, CMCD has been, massive for us and I think for many of our peers in the industry in terms of actually having real data to understand the client-side experience. And it's not to say that it didn't exist 3 or 4 years ago. There was RUM, there was other techniques, but the techniques were pretty disparate in terms of how they operated, or they were vendor-specific. And quite often back then, 3, 4, 5 years ago, you'd run a large event. And if they weren't using your end-to-end stack, they'd say, how did it go? And you go, well, it came off the CDNs clean. It came off the mid-tier cache clean. As best we can tell, it's gone well, but we didn't have that kind of uniform client-side insights to really understand how it's gone. So, I think it's just a phenomenal kind of advancement for the space. And I think it ties back to pretty much what all the panelists have spoken about, because you can use that information to make decisions on contribution. You can use that information to make real-time decisions on which bit rate lanes you might want to include or drop for a high-profile, high-scale event. So, it's I think that's really brought it all together, and it can really inform all the decisions that we make from contribution to transcode and play out.
That's really exciting. Actually, I'm going to throw in an unprompted question and ask, what do you see the development next in our observability? So the CMCD is going now, like how is that evolving for the
I
next?
think it's just kind of echoing what I've said. I think making real time or near real time decisions based on what the client experience is, I think is going to be important. Like if you're spending all this energy making 6 bit rate lanes and only 3 of them are being used, you can make a decision to conserve resources. And we're all talking about the greening of streaming these days. So if we're consuming less data center resources, we're emitting less CO2. I think that's a net positive, and controlling bandwidth that's going out on the wire as well. So I think that's just a example, but I think it's got applicability to make better decisions down the pipe for live and on demand context.
That's really cool. Thank you, James. I'm going to move to our next topic and ask, and switch gears a little bit, and look back and say, over the last 20 years or so, we've seen the rise of generic IT hardware. We talked just about data center efficiency. Before, there were no data centers doing processing video. It was all custom hardware in racks, in broadcast units. And we've seen this rise for media processing and consumption, both because the client devices and the phones have gotten much more sophisticated, so they can do more processing as well, both for transmission and receiving, and the TVs, etc. We're seeing the rise now of custom hardware as part of that flow, to accelerate processing and to make playback more efficient, to drain the battery less. What trade-offs do you see when we're investing in the power efficiency of custom hardware? How is that being traded off with other advancements that we'd love to see? Tamar, I'd love to come to you first here, and let you noodle on this question.
So it's a great question. And being a dinosaur, I do remember the days where encoding a video was black boxes, DSPs, ASICs inside. And over the years, as CPU power grew and Moore's law was, in its element, software encoding became much, much more popular and, across the board. But I look at the video today and there are so many challenges across so many dimensions, because there's an explosion. There are cameras everywhere. All of us are walking around with, this 4K or at least full HD, often HDR, 10-bit, 60, 120 frames per second, creating this video. And there are a lot of more complex workflows, low latency, whether it's a few hundred milliseconds for live streaming or even a dozen milliseconds for immersive video. So we've got that making things more complicated. Then for a long time, H.264 AVC was, pretty dominant on the scene. Finally, we're starting to see adoption of better compression efficiency, more sophisticated codecs, and that adds more complexity and processing demands to the process. So when you put everything together and add to the fact that the CPU isn't growing and increasing in power in the rates that it was predicted by Moore's law, because we're kind of reaching a saturation point. Putting all that together, basically, I think the switch to hardware for encoding at scale is inevitable. Now, obviously, hardware encoding has a significant benefit of reduced power, low latency, cutting back costs, but it comes at a price. It comes at a price of lower flexibility of the encoder. And you have the limitations of whatever hardware encoder you have. And generally, if you're not Meta or Google or, some other empire, you can't really build your own platform, and you have to make do with the hardware encoders that are on the market. So we've actually, as I mentioned, been fortunate to partner with NVIDIA and create a hybrid solution where we use the NVIDIA NVENC hardware encoder underneath. And we've ported our content adaptive technology to the GPU to run very closely with the hardware encoder. And this essentially gives a hybrid solution that can enjoy the benefits of both worlds. So we've seen that, we can cut costs by a factor of 10 compared to a software solution that was, of course, also heavily optimized just by using this underlying hardware encoder and a GPU kind of optimization over it. And a huge advantage is that it means that in the workflows that have GPU processing, the encoding is already done on that GPU and the raw data is there. So I think that's a good point to hand over to James, because I know he has something to say on that point.
Yeah, absolutely. I think we've really ridden the wave as well in terms of leveraging, what started off as sort of consumer hardware from NVIDIA. Like, yeah, we've had less to do with sort of ASIC type stuff and more to do with sort of leveraging, this evolution of NVIDIA GPUs that perhaps was driven by gaming and, life sciences and machine learning, but ultimately has turned out to be quite effective for media processing. So yeah, it was, I think until quite recently, it was quite a trade-off between video fidelity and achieving cost-effective scale. So we certainly got in early. It got us that scale, but, I think the quality was lacking for the more discerning customer that's super concerned about video quality. But, ultimately, there's been a bit of a commodification of live streaming, and it's kind of helped, meet the aims of providing cost-effective solutions for customers. So, we were sort of in early at the, Kepler or Pascal stage in terms of leveraging it in our stack. It's only quite recently with, the 2080 RTX or the T4 in the data center that it got to the level of fidelity that we thought was good enough to roll out to, more sophisticated use cases where there's more fidelity required, whether it's AR or VR or, 1080, 60 frame, sports content. Like it was getting, finally to the point where it was comparable to the gold standard, X264 type processing. So that was a really exciting step for us. And that's let us kind of baseline on that as, one of our dominant platforms. And then it's continuing to evolve now. All this great codec work that's happening, for instance, in the AV space is going to get unlocked by the latest generation, where we finally do have AV1, GPU accelerated encoding, where it was just as great as it was, not practical again, unless you're at a meta scale for us to kind of bring that into our pipeline and actually offer timely AV1 type encoding and to reap the benefits of that approach. So yeah, we'll continue to watch the space, but it's been a game changer for us.
Cool. Thank you, James and Tamar, for taking us through your experiences. Haixa, I'd love to come to you to talk about Meta's experiences adopting hardware and the trade-offs that we've had to make as a company.
Yeah, so interestingly, even though I want to talk more about experiences Meta, which is more of a custom ASIC-based hardware encoding accelerator, I find that the observations are largely similar. At the beginning, the power efficiency and compute is such an important factor to consider. But the fact is that the hardware encoder is just perceived to be inferior compared to the software encoder's compression efficiency and quality and fidelity. And that was like what is holding it back on a large-scale adoption. There's too much trade-off to be made, and then people are hesitant to onboard the production encoding pipeline onto this. And there was this magical threshold moment where the new generation of the ASIC suddenly becomes good enough, and then it becomes like really compelling for all the teams to onboard to this system. And I think that the similar thing will also happen if, for example, the next generation or something that gives a good enough experience for advanced codec like AV1, that would probably be the moment where we are starting to see the shift of the workload onto ASIC as well. I'm probably going to give back to Robert also on this.
Yeah, so as we've already established, I like to go back to the beginning, so I'm going to continue doing that. And, the beginning of my journey with video stuff, we had kind of bigger, different challenges than what we have right now. So storage in particular was an interesting problem. This was the days of tape. And it started off as analog, and eventually we got digital, but it was still a problem. Like, how did you do the things that you were going to do? The computers didn't have the bandwidth internally, like the bus itself didn't have the bandwidth to do multiple videos. So we started kind of with storage as the bottleneck, and then we got to like bandwidth within the computer itself was the bottleneck. And so, that was generally solved at the time by custom stuff. And one of the big players in the industry back when was SGI, who no longer exist. And they got replaced with, more generic PCs as Moore's law really started kicking butt. And at that time, we saw also kind of the advent of GPUs come in. And we could solve some of the video problems with the limited programmability that we had on these newfangled, supposedly for gaming devices. And so we've come to learn they definitely have more use cases than just gaming these days. And then we started to see that the problem changed. It was the same problem in a sense, but the scale went bigger. So now we were looking at, instead of just doing like video that was broadcast to everybody in exactly the same bits, now we're doing it over a network where people have different varying requirements. And so now what we need to do is make multiple streams of encoding so that people can tractably pick, the one that actually matches the best. And then, of course, that started the storage problem again, became interesting, as James brought up before with the CDN. And of course, these two are very interlinked in fun ways. And so we've seen this cycle start up again. And that's true on the storage side and it's true on the processing side. So right now what we have is ASICs that are not obviously user reprogrammable. And it's really interesting that we're seeing, hopefully, some more motion towards being able to do with video codecs what we've seen being done with graphics stuff. So programmable things of, not infinite function, but more than purely fixed function that really makes for innovation in the space. And I'm really excited to see where we end up going in the cycle again. So we've made custom silicon. We are doing that across the industry to make things cheap enough. But now we're maybe thinking about making it somewhat programmable, or I hope we are, so that we can get some of that innovation back. So that's kind of what I'm excited about, is that, it seems like we keep going through these cycles. We're going through another cycle right now. And right now it's specific hardware in the ascendance. And then I think we're going to add the programmability back.
Really cool. Haixa, I'm going to come back to you actually for an unprompted question, because as you were speaking, I thought back to Tamar's response earlier about quality in the loop was game changer for end user experience. How should we think about quality in the loop when it comes to selecting hardware in terms of hardware encoders on that side? I'd love just to hear like 30 seconds on how you think about quality measurement when it comes to migrating from software to hardware.
Yeah, I think the general rule of thumb that I think about it is that we try to benchmark the hardware encoders compression efficiency in terms of like an objective metrics like a BD rate based on SSIM or VMAF, and really trying to see how well it can produce the encodings at a certain bit rate at a certain quality bar. Because I think at the end of the day, that is what really makes a huge it's a factor in the decision-making process for team to think, is this like a huge trade-off, or is this something that is so compelling that we should just have no-brainer to adopt it?
Yeah, that makes tons of sense. Thank you, Haixa. I'm going to move on to our next topic. We have seen like this huge change in video processing workflows over the years. A very significant increase in complexity from content creation through to processing and coding, where we've been integrating more and more tools, be it ML tools or AR tools. I'd love to hear from each of the panelists, like what are some of the challenges that come with this increasing complexity, and how are you starting to think about addressing them in your workflows and in your systems? I'd love to take it to James first to hear your thoughts on this topic.
Yeah, absolutely. I think to some of the earlier points that have been made, like, yeah, there are less trade-offs now that we're beholden to. So I think, if we can move to more efficient encoding codecs, AV1 just as an example. There'll always be new codecs coming down the pipe. At scale, if you can get a 20 to 30% decrease in content stored and content transferred at essentially the same fidelity level at petabyte scale and beyond, that's massive. So that's it's cost savings, it's efficiency savings, it's energy savings. So I think it's really compelling for everyone in the space to move to those more efficient codecs. And I think the content itself, as some of us have touched on, it's becoming richer and richer. We're being pushed to deal with 2K, 4K, 6K, 72 FPS, 90 FPS content for immersive applications. So you can imagine just the content size is just ballooning as well. So how we did things 3-4 years ago is not really going to cut it for those types of applications. So that's obviously a big driver to have workflows that can deal with that level of complexity and richness of content. And I'll just touch on quickly. We deal with quite a diverse range of content, whether it's for internal, applications that are quite sensitive, all the way through to external broadcast type applications. But even in the internal space, like with the sensitive content we deal with, like there's a lot of AI and ML applications at the moment around data privacy in terms of redacting sensitive information or faces or things like that that we're working on. My colleagues are working on, training models to better handle those types of situations, to deal with, complex regulatory requirements around storing private information. So, that's a bit of a niche, perhaps, application of AI and ML, but, that's just an example of, I guess, what's going on in the space.
And to see that coming off client and into the server side, so we start to see this amalgamation of things living in the middle, and less happening on the production side and less happening on the client side. It's really interesting. I'd love to hand the topic to Haixa next, and how Meta, what your experience at IG has been for this ever-growing complexity, and how you're thinking about what's coming next. Okay.
Hello.
Cool. I'm going to go on to Roberto because we're having some tech difficulties just at this moment. Roberto, do you want to take the question next?
Sure. So my observation is that the whole pipeline is utterly different right now than it was even like 4 years ago, which for anybody in the tech industry is kind of like, well, yeah, of course. But that hasn't historically been true for video. Things have not changed that fast in this area. But recently they have. And so, the first thing that I think is quite different is that everything tends to start with a mobile device. It's your camera, it's your friend, it's your storage. And you also make yourself look better, or maybe somebody else look better, and you put little sparkles and stuff with filters and such on these. And that's kind of the first part of production that many folk are going to see. And so we're seeing basically a whole lot of client-side processing or client-side pre-processing that makes life interesting for everybody. Some of the quality things that we were talking about before actually get a little confounded by some of these things. When do you reprocess? Are we putting text on it? Like, video doesn't normally have a lot of crisp, clear, supposed to read it nicely text on it. If we're putting those things on filters and then we're uploading them, we're doing something again to it, re-encoding them. Like, how do you deal with that? These are all fun new problems because so much of video production is newly on these client devices. And then, of course, we bring up the connectivity issues. When we were doing things on big, beefy, PCs or cloud servers, those things were fairly well connected. We didn't have to deal with hiccups as much in the connectivity, both, whether it was connected, period, or not, or also like, did the latency change because we went from the West Coast to the East Coast or across a different continent? Like, those things are way more common now, and we have to deal with those. And then the user experience itself is diverse and different depending on what phone and what app and all of these things. So we've had kind of a lot more variation crop up as people are using the devices to do it that way. And of course, none of that is really talking about the fact that we've also seen sea changes in the cloud side. It's just that the changes on the client side to me are really amazingly huge.
It's really cool. Yeah, I see those too, and I see our complexity growing as a client surface. Tamar, I'd love to take the topic to you.
So I obviously agree with everything that's been said, and I want to touch maybe on a slightly different angle. I agree with what Jane said about, needing the better codecs because the complexity of the workflow is growing. But I think we're seeing another interesting thing, and Roberto touched on it. We're seeing companies and the kind of researchers that never really dealt with video, so machine learning experts and analysis and all sorts of AI experts creating videos, analyzing videos. And the video is getting even more and more valuable, right? Because we're doing all sorts of things with it. But these are companies that don't necessarily have in-house video encoding expertise. And on the other hand, they're dealing with this mass of video content, which, the huge storage, huge bandwidth bottlenecks to pass things around. If you want to do training on video, well, good luck with that. And I think this is something that we're actually tackling at Beamer is we call it democratizing the access to sophisticated video encoders by being able to take an underlying hardware solution that is cheap and wrapping it in a technology that kind of makes it accessible. And you can do something we call codec modernization, which is just take your video. You don't have to be a video expert. You don't have to know the FFmpeg parameters. You don't have to read the manual. And, we'll just preserve the perceptual quality and get a better compression efficiency, reduce the bit rate. And I think so. I really think that's one of the interesting things. If we were always kind of a closed world of video compressionists and geeks that knew the bits and bytes and the standards, a lot of people need access to good video compression. And we really see it as one of our goals to sort of open this up.
Really cool. As you were speaking, I was thinking about our next year's panel. We should talk about storage. Like all the value of video is growing. How do we start to unlock that value even more? It's a really interesting topic area. Haixa, I'd love to finish this topic with you and give you the microphone for a little bit.
Yeah, so in terms of complexity in video processing, I think one of the angles that I want to talk about is high dynamic range or HDR video, because a lot of the things that we talked about higher and higher resolution and frame rate, but HDR just throws in a completely new dimension to it. And this is something that is very hard to do end to end, because you have to have an unbroken chain of custody of the correct color space all the way to consumption. So I think, and this goes beyond just video compression. It also has to do with how you do video processing, rendering, mixing, all the effects in AR correctly in HDR. I certainly find this has been one of the most challenging things at IG for the past couple of years. And I think this will continue to be an unsolved problem in the future with all the things like how do you mix HDR and SDR content, effects that used to be programmed only in 8-bit. Now you have to support this, and including the correct handling of brightness and things like that at the playback side. So I think, yeah, that's definitely something new in the last few years, but it will continue to be a big problem.
Yeah, it kind of makes me curious about, we talk about ML effects and Gen AI, like are we expecting Gen AI HDR output, and then how we process that as we see that going in the chain? It's a really interesting topic area. I'm conscious of time. We're slightly over, but we're going to take just a couple more minutes, and then we'll hand you to the closing. I hope our audience is sticking with us just for a minute or two more. And I'd love to hear from the panelists just a closing thought to leave our audience with. Haixa, I'd love to come back to you to give your closing thought for this panel session.
Yeah, so just to summarize it in one or two sentences, I feel like now at the beginning of the second decade, it's a really interesting time. If we go back 2 decades, I think AVC or H.264 has been the king of the hill for a very, very long time. It's sort of like the position JPEG was in. And now I kind of feel like AV1 is a really good replacement, and it will probably be establishing itself for the foreseeable future. And we're still like very early at the adoption of this. So I'm very, very excited to see how this will bring like much improved compression efficiency and QoE going down forward.
Really cool. Thank you, Haixa. Tamar, I want to hand the microphone to you.
So I completely agree, and I want to reinforce Haisha's statement. I think we're seeing video workflows that are very demanding. I think we're at a tipping point where, exactly as you said, 264 is going to have to give way to more modern codecs. I think given the volume, the low latency, and the so many different areas where video is starting to be more used, not just video conferencing and streaming video. It really is in every single aspect of our lives. I think that hardware is inevitable. The switch over at least to combined solutions with hardware is inevitable. And as James mentioned, we're at a tipping point there, okay, where solutions are getting better, but we need to be able to offer a window into innovation, as Roberto said. And I think hybrid solutions like the one we've developed with NVIDIA and the APIs that they opened for us to be able to do that allow for innovation and, hybrid solutions that are software, hardware, moving to newer codecs, quality aware in the middle of all that. I think that's the only way we can really tackle the challenges that face the video at scale community that we've touched on here today.
Very insightful. Thank you, Tamar. I'm going to head to James. How would you like to close the thoughts here?
Yeah, I mean, I don't think everyone here on the panel is certainly not going to stand still in terms of new innovation, but I think that a lot of the things that we've been waiting for are sort of here, and they're accessible and they're affordable. So there's really not a big excuse to not be leveraging these new approaches and new techniques. And we've got standardization finally becoming a bit more solid in terms of low latency delivery, which is comparable to broadcasts. And we've got all these great things we can bring to bear to deliver really rich solutions. And I'll just maybe quickly touch on one thing that we haven't sort of mentioned on this panel is, I'm personally, or we as a company are quite excited about the advances at the edge as well, in terms of, again, something that was just totally not possible 3 or 4 years ago in terms of the level of personalization that you can offer in terms of the video content and real-time manipulation of that. Not everyone's favorite topic, but, novel scalable ways to do DRM as well. They're all being really unlocked by the broad-based availability of edge compute that can manipulate, quite rich video on the fly. So we're quite excited about what that brings as well.
Yeah, 100%. I'm conscious, as you say, we didn't talk to edge at this just due to lack of time, right? It's a huge topic, and I think one that would definitely be addressed
Absolutely.
in future ones. Really looking forward to that. Roberto, I'm going to give you the final slot. Please finish our discussion.
All right, thanks. I think for me, my observation is that the journey is still ongoing. We're not done. We're probably not close to done. We've seen a continuous line of innovation. And what is different, I think, right now is that we're getting a little bit surprised by some of the innovation. The innovations that are coming out aren't all obvious. And I think part of that is the world has changed out from under us in ways that were hard to predict. We already know about the mobile stuff. Now we see the AI stuff. We know about codecs, but even today's, new codecs are still based on some kind of old beliefs. One of the ways we can think about AI models are that they are a compression scheme. This is debatable, but that's one of the ways you can think about it. They're a compression scheme for probabilistic things. Well, that's video too, right? So what about the marriage of these things? Are we going to have much larger dictionaries that allow us to hallucinate what seems like higher quality content, perceptual quality as compared to PSNR quality, right? I think the answer is probably yes. So I think there are probably other beliefs that we have held for a long time that stemmed from the beginning of our experiences with the hardware that was available 20 something years ago that probably don't hold anymore. So I'm really excited about seeing how that's going to change and how we're going to go into the future from that.
Awesome. Thank you, Roberto. I want to extend our thanks to all of our panelists. Thank you so much for your time, for sharing your knowledge with this group. And I also want to thank our audience. Thank you for listening for us. I hope you learned a bunch. Feedback is a gift. Always don't hesitate to reach out. And yeah, have a lovely day. Thank you very much for your time, everyone.